Okay, guys, so 5.11, we're dealing with common factoring. Okay, so common factoring, as I mentioned, is going to be used for the next few years of your kind of math career, and it's something that's pretty important you get a good grasp on. So we're going to talk about a few things, and the first is review of multiplication of a monomial, right? So one term, and a polynomial, or two terms. So to divide a monomial with a polynomial, you must multiply the monomial by each of the terms in the polynomial using the distributive law. Or what you've seen before is just that number on the outside has to be multiplied there, and it has to be multiplied here. So once again, if we look at that example, 3 times x is 3x, and 3 times positive 2 being 6. So our answer being 3x plus 6. If we look at our next example, 5 times 2y would be 10y. And 5 times negative 3 is negative 15, giving us the answer of 10y minus 15. For our next one, we have the, sorry? Oh, sorry about that. We're good now? Sweet. Sorry, guys. So again, it's x squared times x and x squared times positive 6. Remember, when we're multiplying with exponents, we just add them. So the x by itself, we imagine there's a 1 up there. So it'd be x to the 3 and then 6x squared. Okay. For our final example here, once again, we're multiplying in by both the terms. So n to the 3 times 2 would be 2n to the 3. And then n to the 3 multiplied by negative 11n squared. Remember, we add the 3 and the 2, giving us n to the 5. And then we have negative 11 in there. So it would look like this. Okay. So that's where we're at right now. So now we're going to get into what we call common factoring, or we talk about the greatest common factor, or the GCF. You'll probably see that quite often. So that is basically the largest number that we can divide each term by, okay? So that's important to note. Largest number we can divide each term by, and its largest number and variable, okay? And you'll see that happen very often, okay? So our job is to take the largest number that divides evenly into all numerical and the variables that are common to all terms with the lowest exponent. So that means if I had, say, x to the 4 and an x to the 2, well, we know that this is also found in that. So if we went to do the greatest common factor of that, it would actually be x squared. And then to get x to the 4, we'd have to multiply that by another x squared and just by itself to get that. And we'll go over that. But basically, we're finding the greatest common factor in which terms share. So for this one here, we see that if we look at these terms right here, we can see that 6 multiples of 6 would be 2 times 3, 6 times 1, and multiples of 3 would be just 3 times 1. So they share 3. So 3 would be our greatest common factor because we can divide 3x by 3, and we can divide 6 by 3. So when that happens, what we do is we actually put those numbers outside the bracket. So since 3 is our greatest common factor, we put that outside the bracket, and then inside we would have, if we divided 3x by 3, it would just be x, and if we divided 6 by 3, it would be 2. And the reason we do this is basically to short form multiplying it through. So if we multiplied both of these terms, 3 times x would be 3x, and 3 times 2 would be 6. So that's what we started with. But to common factor, we want to end up with this term right here. Okay? So if we look at our next example here, if we think about multiples of 10, we got 5 and 2, we got 10 and 1. And if we think of 15, 15 and 1, 5 and 3. And by just looking at this, we can tell that, well, 5 is going to be used. So in this case, 10y divided by 5 and negative 15 divided by 5 will help us get what we need inside the bracket. So outside, we know our GCF is 5, our greatest common factor, so it would be 5, bracket, 10y divided by 5 is 2y, and negative 15 divided by 5 is 3. So we've ended up with this factored form, or greatest common factor, of that term 10y minus 15. So it's basically just the opposite of what we've been doing, but we're showing how we can get to that based on having couple terms. If we look at the next one here, we have 18m squared minus 24. If we just look at some things, we can get 18 times 1, obviously, 9 times 2, 6 times 3. That's about it we can do. With 24, we've got 24 times 1, 12 times 2, 8 times 3, and 6 times 4. So if we look at all these different things here, the two numbers that would match would be our 6, and therefore our GCF would be 6. So if we took these two terms and we divided them by 6, we'll find out what's in the bracket. So 18m squared divided by 6 would be 3m squared, and negative 24 divided by 6 would be minus 4. And we know outside the bracket is our greatest common factor of 6. Okay, so I'll give you a second to write that down. I believe there's one more question on a couple more questions on the back side. We'll just go over those quickly. And our answers here are like so. Okay, so now it is common factoring using a variable only. So sometimes we don't have any numbers that work out to be the same, but we do have variables. So once again, variables are that letter or literal coefficient that we've talked about. So in this case, we see that there's nothing in front of this x, but there's a 6. So in front, it would just be a 1. So therefore, we're going to have to use the variables. So we see that both have x's. And when a hint for you would be when you have x's or the same terms, you'd use the lowest term that would go into both. So x to the 3 is higher than x to the 2. So x to the 3 can't go into x to the 2, but x to the 2 can go into x to the 3. So that would be our greatest common factor. So our greatest common factor would be x squared. And you'll see what I mean by that. So if we divide x to the 3 by x to the 2, we know we just subtract. So we would be left with x. And if we did 6 x squared divided by x squared, we know that we would do subtraction here, so these two would cancel, and we'd be just left with plus 6. So our factored form would be, we take that greatest common factor and we put it in front of the bracket, and we're left with x squared bracket x plus 6, meaning if we multiplied this inside of it, we'd come up with the same answer we started with. Okay? Again, guys, this just takes a little bit of practice. The more you work at it, the more comfortable you'll get with it. Promise you. Okay, for our next one, since 2 and 11 aren't multiples of each other, or they can't do the same thing, we're going to deal with the variables only. So we have n to the 3 and n to the 5. Like I told you, n to the 3 can go into n to the 5, but n to the 5 cannot go to n to the 3. So therefore, our greatest common factor would be n to the 3. Okay? Now, I'm going to leave that down here. And I'm just going to continue with doing exactly what we've done before. So we divide each term by n to the 3. So in the first one, we would have 2n to the 3 divided by n to the 3. Well, those cancel out because they're the same. So that would leave us with 2. And then negative 11 n to the 5 and n to the 3. Well, the numbers, there's no numbers there, so it's minus 11. And then it would be n to the 5 minus, or divided by n to the 3. So we just do 5 minus 3. So it'd be n to the 2. And that is our common factored form of 2n cubed minus 11n to the 5. All right. Last example here is a little bit trickier because it's got 3 terms. But once again, we have the platform set that we know we're only using variables. But if you looked at all these numbers, 3, 1, and 7, they don't share any multiples. And that's kind of what you need to look for each time. So since they don't share any multiples, but they do share variables, we can work with that. So in this case, y to the 3 would be the highest, y to the 2 second highest, and y. So we gotta, it says greatest common factor, meaning basically the lowest thing we can multiply through. And in this case, it would just be y, because y can go into y to the 3, and y can go in y to the 2, but it cannot go, the others cannot just go into y. So the greatest common factor would be y. And just like we did in those last terms, we're going to divide each one by y. So we just set it up like so. Okay. And we just attack each one like we have been in the past. Now we know we have y outside the bracket. So inside right here, 3y cubed divided by y. So the 3 is there because it's just 3 divided by 1. And then the y cubed divided by y would be y with a 1. So it would be y 3 minus 1. It would be y squared. And then after this, we'd have y squared divided by y. Remember, once again, we have that imaginary 1 there. We do y to the 2, subtract 1, so it would just be y. And then in our last one here, we have negative 7, and the y's cancel themselves out. So our greatest common factored form of 3y cubed plus y squared minus 7y would be y bracket 3y squared plus y minus 7 closed bracket.